We're going to add these two fractions together, and you can see that the answer in this one is split up differently than the circles in our equation, and we will find out why in a minute. So our first equation, our first picture is showing us that there are 4 triangles shaded in, and we have 8 total, so that means that we have 4/8. Plus we are going to add, we have 2 shaded in, and there are still 8 total. Now before we look at our picture, we are just going to add these two fractions together. So we know that we always keep the denominator the same, we never add it together. So we're just going to leave that as 8. We're going to add the numerators together, so that would be 6. So our answer is 6/8, but as we can see, our picture is divided into fourths. So we know that we want to find an equivalent fraction that is fourths. If we think back to finding equivalent fractions that we did a few weeks ago, you might remember that in order to get to an equivalent fraction, we could just think of how we would multiply or divide in order to get there. So we could say 8 divided by 2 would give us 4. If we do that to the bottom, then we have to do the same to the top. So we would do 6 divided by 2, and that would give us 3. So we can say that 6/8 is equivalent to 3/4. So we can go ahead and shade in 3/4. If you think about rearranging our pictures over here, so this would be showing 2/8. So if we're looking at that like it's divided into fourths, we can kind of picture it like this. So this would be the same as 1/4. And then if we rearrange the picture over here, we can see that this would also be split into fourths. And we could see that this is 2 of the fourths. So here's a fourth, and here is a fourth. So here's 2/4. And now if we look at them together, 2/4 plus our 1/4 is going to be equivalent to our 3/4. So it's the same kind of concept, we just are doing the numbers first and then thinking about what the picture is going to represent.